this Jeld-Wen window failed 4 days after its installation. It developed a crack at the corner here. Now Jeld-Wen replaced it on the warranty within 4 weeks, maybe 6 weeks tops, and the replacement window was delivered at the site at the retailer where I picked this one up from. No issues there. In this video I want to share a little bit about how and why plastics fail and whose fault is this crack. Let's start by taking a look at this crack up close, really close, just like so. You can see that the crack starts at the mitered corner here, at the plastic weld seam. You see that I know that it starts here because this is where the crack is the widest. You can see some light coming through it. The gap is that wide, and then the gap propagates or continues in this direction and tapers to ever narrower and narrower. The gap seems to stop there at this corner. It doesn't seem to spread on this flange here. We have another look at this crack from this side. Let me just set up the camera here. So you can see there we have it on the inside, that this plastic part is cracked through its entire thickness, and the crack continues on this part of the frame there, tapering to ever narrower and narrower, and it stops short of the other mitered corner there. So that's how this looks like. There's no sign of surface impact, there is no chipping, there's no denting, there's no abrasion, no scuff marks, nothing else, just a single crack. So how did this come about? First off, who's not at fault? It's not the fault of the installer. If a window gets chipped during or damaged during installation, it's possibly that the flanges break off. Here's the window frame here. This is just the same window frame this window is made of, just gray. Here is a nailing flange on it. You can see underneath the window. This part is the nailing flange. The nailing flanges are likely to get damaged, and if the window is rocked too much around corners, then the glass is likely to crack, and other corners are likely to be involved. But it's only one corner, and it's actually just half of one corner. So it's not shipping, it's not installation, it's not delivery, and it's not the expanding foam either. You can see there's a bead of expanding foam behind it, and that didn't crack it either, because the crack is widest here at the plastic weld. So this is a manufacturing mistake. This mistake happened at the place of manufacturing when this plastic weld was made. Let me just show you that this is a chunk of this frame, like I said, and it gets cut on a miter saw like this, and two of these miter pieces, this one and this one, get welded together at the corners like this, all around the frame. So starting here all the way down to the tip of the frame, all across at the bottom, and up on a 45 degree at the other corner here. So that's where the plastic weld stops. So this is a manufacturing mistake which is caused by thermal shock. This thermal shock is due to this plastic weld here. To join this piece and this piece together, the ends that meet at this miter need to be heated up to a melting temperature to ensure fusion, proper fusion and proper joining between these two plastic pieces. Much like in welding and joining metal, there is a heat affected zone. So if the melting temperature here is, say, 150, then the temperature here is 130, 110, 180, 70, 60. You get the idea. So there's a heat affected zone that extends about this far out from the plastic weld there. That's the heat affected zone. Now, if these ones, if this extrusion here is cold, and this one is also cold, these cold surfaces act as a heat sink and they wick away heat rapidly from this hot seam here. Alright, in this direction they wick away heat. Now, at this corner, this part seems to cool the fastest, as evidenced by this crack. That's why this crack is widest at the corner here. And because it cools fastest in about this region here, that's where it shrinks most aggressively, and it shrinks less aggressively here and here. So again, this did not crack at the site of manufacturing, so that's nice theory with shrinkage. What happened here? Well, plastics and metals and material, they solidify and they stop shrinking. But when they solidify and the temperatures even out, but they develop internal stresses. This seam was pulling the material towards the seam here in this direction, like there, in this direction, and the rest of the material that did not get affected much by this shrinkage is pulling the plastic molecules in this direction. All right, even after solidification. Okay, there. So the forces are greatest here, pulling the heat affected and the not heat affected zones apart here, and less so much here and here. All right, so that's why it cracks days after manufacturing, days after quality control at the manufacturer's site. It cannot be caught at the manufacturer's site because the crack is not visible at that point. The internal stresses are there, but the material tears itself apart a little later, much like honey, liquid at first, solidifies and crystallizes later. Okay, something like this. When it's liquid and it's hot, it looks good. When it solidifies, it looks good. A month later, maybe it still looks good, but eventually the internal stresses cause it to crack. So why did this corner fail only and not any other corners? So that means that the piece was handled properly. This for proper manufacturing, this piece has to be preheated, this piece has to be preheated and cooled down in a controlled environment to avoid thermal shock to the joint there. Probably there was a sudden draft that hit only this corner and only this surface here, because there are no cracks on the opposite corner, no cracks up, no cracks anywhere else on the window. So it was a sudden blast of air, some kind of draft that hit only this corner here at the manufacturer's site when the rig that's applied around plastic molding was opened for a second or so. So it's a manufacturing problem, and it's really hard to control it.